Hello, we are Dawon Lee and Minsun Kim from KAIST. We'll be presenting our paper titled Generating Highlight Video of a User-Specified Length Using Most Replayed Data. Highlights is a short edit of the original video that includes the most engaging or important moments. These highlights are often utilized in TV broadcasts as a footage of summarizing a specific event, and they are also easily found in many social media platforms. Since these platforms favor a brief format, highlights are often produced as a short-form content with a concise runtime. Regarding their practical use, highlights often need to be created to fit a specific length. In the case of TV broadcasts, they must be produced to fit the exact allotted time slot and adhere to strict advertising or program schedules. When they are posted to social media, each platform has its own maximum video length limit for uploads, and the preferred content duration varies across platforms. Therefore, to align with platform-specific characteristics and guidelines, highlights should be considered as time constraint when being created. Although there are a lot of automated methods for generating highlights or summarized video in the field of computer vision and computer graphics, all prior methods generate highlights of arbitrary lengths. Because they focus only on how effectively to summarize the video, thus they did not consider the length of the final output. Therefore, even with input videos of the same length, their methodology could produce highlights of different lengths depending on contents, and the length is neither predictable nor controllable. In response to this problem, our goal is to develop a system for auto-generating highlights of a user-specified length for the first time. If a user wants a 30-second highlight, our system generates 30-second highlights. Or if a user wants a 60-second highlight, then our system generates 60 seconds highlights. It also works for any other specified lengths like 100 seconds, 3 minutes, 5 minutes, etc. So to achieve it, we need a process that involves finding engaging moments in the video for effective summarization and optimizing internal segment duration to fit to a user-specified length. This is our research idea. First, to gauge engaging moments in the video, we use most replayed data called MRD, the white curve in the figure. The curve highlights the most popular part of the video that viewers have replayed. In our investigation, it actually aligned very well with specific events in the video, such as goals in the soccer video. MLD also showed a high correlation with other known engaging factors. So our concept is to gauge a user engaging moment via MRD, and to generate highlights to fit a user-specified length, we optimize internal segment durations. As you can see, increasing the user-specified length allows more key moments to be included, and the length of each segment may also vary to meet the desired length. Now I will hand my mic over to Minsun. She will explain how our method was developed.
Our method is straightforward and intuitive. First, we obtain the MRD graph from the YouTube video player interface. It is sampled at 1 second intervals, and we select timestamps matching the user-specified highlights length L-user. For instance, if the user-specified length is 8 seconds, we select 8 timestamps. Each selected timestamp is assigned a reward according to the reward function, which considers two factors, R MRD and R duration. First, high MRD values yield high MRD rewards. For example, selecting timestamps from high MRD areas yield a high total reward, whereas selecting from low MRD areas will yield a low total reward. Second, the duration reward will be high when the segments had adequate duration. This reward is implemented through the equation that takes the segment duration d. This is designed to gradually increase rewards for segments with adequate durations based on the cinematographic principles, and decrease reward for segments that are excessively short. In the case of this red excessively short segment, when its length d' is applied in the equation, duration reward becomes a negative value, ultimately penalizing the total reward. This prevents starring transitions and allowing viewers sufficient time to grasp the content. Ultimately, there can be hundreds or even thousands of different segment combinations, varying in both the number, composition, and duration of segments. Segments with high MRD values and appropriate durations yield high total sum of rewards, and our method employs dynamic programming to select the optimal highlights. Now let's see the results of our method. As you can see here, as the user-specified length increases, more segments are included. 3 segments for 30 seconds, 4 segments for 60 seconds, and 7 segments for 90 seconds. Simultaneously, each segment's duration is optimized accordingly to fit the user-specified length. Here are additional results from various video genres, including audition, sports, and music concert with different user-specified lengths. For more details about the method and additional video results, please refer to our paper and project page. Our method also allows user-driven highlights customization, enabling users to specify timestamps to include or exclude from the highlights. This customization is achieved by increasing or decreasing the MRD values at the selected timestamps. In the case when user selects this timestamp, the MRD reward is weighted higher around this timestamp, resulting in segments containing this timestamp being included in the final highlights. Here is an example of customization. The highlight on the left is generated by selecting timestamps of player A's 10-point shots, while the highlight on the right is generated by player B's 10-point shots. We conducted 2 comprehensive user studies to demonstrate the effectiveness of our method. In the first user study, we compared our method with previous methods. We generated 3 versions of highlights with same lengths. First, our method. Second, a threshold-based method, which naively selects timestamps based on the highest MRD scores. And third, a random selection method, which randomly chooses segments without considering MRD. Participants rated each highlight regarding segment duration appropriateness, key moment inclusion, and overall satisfaction. Results show that highlights generated by our method receive significantly higher scores compared to the previous method. In the second user study, participants compared highlights generated by our method against human-edited highlights, all edited from the same original footage. For the human-edited highlights, we used those already uploaded on YouTube and set our method user-specified lengths to match those human-created highlights. After watching these 2 versions, participants were asked to select their preference among 3 options: our method, human-edited, or equal preference. The analysis revealed no statistically significant differences between ours and human-edited highlight, indicating our method can successfully produce highlights comparable in quality to those created by human editors. Our method can be applied to all videos even when MRD is unavailable. For example, videos not uploaded to YouTube or those with low view counts. In these cases, our method employs a deep learning MRD prediction model. This is 30-second highlights using our method based on the predicted MRD. This shows that predicted MRD also successfully captures engaging key moments in the final highlights. Furthermore, our method also universally applicable to any type of engagement data beyond MRD. Whenever a video is paired with any engagement graph, such as live chatting speed for streaming, TV viewership ratings, or in-video sound loudness and other engagement data, our method can generate highlights. Our method can be extended for more advanced highlight generation, such as adapting to various aspect ratio through automatic region of interest detection, creating subject-specific highlights using person identification, or generating narrative-based highlights using video description models. Our contributions can be summarized as follows. First, we explore the implication of MRD and propose its first application system. Second, we propose the task of generating highlights with user-specified lengths for the first time. Finally, we developed the novel highlight auto-generation system optimized for user-specified lengths. For more details, please refer to our paper and project page. Thank you for watching.